This is half past paper week 23 for the higher tier calculator paper this week, and we've got all the odd numbers. These are all the topics that we're going to have a look at today. 43 marks on this paper, so just over half a past paper, and all the Sparks codes there on the right if you were interested, or you do have access to Sparks, to look them up and have a go at these in more detail. Okay, question number 1. The scatter graph shows information about the volume of traffic and the carbon monoxide level at a point on a road each day for 22 days. One point is an outlier. Write down the coordinates of this point. So the outlier is this point up here. It does not fit the trend of the data. Does not fit the trend of the data. So that is an outlier. And the coordinates, remember we were going along the corridor up the stairs. So 118 is the coordinate of that point. For another day, 370 cars passed the point on the road. Estimate the carbon monoxide level for this day. So what we want to do here, if we're going to read off the graph, we're going to need a line of best fit. Now a line of best fit should go between as many of the points as possible. So you want to kind of try and end up with the same amount of points above and below. Now that is okay. I might go a little bit higher, I think, just to try and be more in the middle of that cluster there. So I think I'm happy with that. It's not perfect because the bottom ones are quite low and in the middle there they go a little bit higher, but I'm happy with that, okay? There would be a range of answers allowed on the mark scheme and I'll let you know what that is in just a second, okay? So we're now going to read up and across. If there are 370 cars, we're going to go to 370, read up until you hit that graph, and then go across. And for me, that comes out there. Now, we need to be very, very careful to read what that is. So this is 2 higher over 5 squares. So 2 divided by 5 is 0.4. So this is going to be 12.4, 12.8, 13.2, 13.6. So my answer is 13.6. Let's have a little look at the mark scheme. 13.6, that should be cubed like that. 13.6. Let's check the mark scheme. You were allowed anything from 12.8 to 14.8, but it did have to come off of your line of best fit correctly, so bear that in mind. So 12.8 to 14.8, where your line of best fit and you've read off it correctly. If you went to there and then said that was 13.9, for example, because you've just gone one square down and you've read it wrong, then you are going to lose that mark, even though it's within the range. So it does need to be correct to your line of best fit. Okay, Alfie says, because there is an outlier, there is no correlation. Is Alfie correct? You must give a reason for your answer. No, so he's not correct. All of the other points have a positive correlation because they are going up. As one piece of data gets bigger, the other piece of data gets bigger as well. Positive correlation. There we go. So just because there's an outlier doesn't mean that all of the other points don't have a pattern to them, and we can see that they are going up. The more volume of traffic on the road, the higher the level of carbon monoxide. Okay, question number 23, and we've got standard form. That should be a power of 5. 4.5 times 10 to the power of 5 as an ordinary number. Okay, so when we do 10 to the power of 5, when we times by 10 to the power of 5, we're timesing by 10, timesing by 10, timesing by 10, timesing by 10, timesing by 10. 5 times, okay? So 4.5 would move, it would become 45, then 450, then 4,500. And it's really the 4 and the 5 that are moving, but it's much easier for us to move the decimal point, even though it's technically not moving. So 1, 2, 3, 4, 5. The decimal point is there. So we fill in these place value holders with zeros. And so 450,000 is that answer as an ordinary number. Then we have to write 0.007 in standard form. Now it's going to be 7, because we need the first digit to be between, the first part of our answer to be between 1 and 10. 7 times 10 to the power of, now if we've divided by 10, divided by 10, divided by 10, which we have here, we started with the 7 in the ones column, 1, 2, 3 over, so it's going to be 7 times 10 to the minus 3, because we've divided by 10, divided by 10, divided by 10. And then for part C, work out 4.2 times 10 to the power of 3, add 5.3 times 10 squared, give your answer in standard form. Now we do have a calculator for this, so you can absolutely just type that in your calculator, but if you didn't have a calculator, you might want to put both of these numbers as ordinary numbers, then add them and put them back. So 4, 2, 0, 0. 4,200, because if I multiplied that by 10 once, twice, 3 times, that's what I would end up with. And then I'm adding on 5.3 times 10 squared. If I times it by 10 once, I get 53. If I times it by 10 again, I get 530. Adding these together, I get 4,730. So that's going to be 4.73. Remember, it has to be between 1 and 10 when you have it in standard form, times 10 to the power of 3. That would get it back in standard form. But again, you can use your calculator for that one if you would like to. Okay, question number 25. The first 4 terms of a Fibonacci sequence are A, 2A, 3A, 5A. The sum of the first 5 terms is 228. Work out the value of A. So a Fibonacci sequence is one where you add this to get the next number in the sequence. So A add 2A is 3A. And then we want to add 2A add 3A, and that gives us 5A. So to get the next term, I'm going to do 3A add 5A, which is 8A. So the next term of this sequence is 8A, which is important because it says the sum. So if we add together the first 5 terms, which we need that one for, we get 228. So A add 2A add 3A add 5A add 8A equals 228. 1A add 2A add 3A add 5A add 8A. If we're collecting like terms there, that makes 19A, and that equals 228. I'm then just going to divide both sides by 19 to find out what the value of A is. So 228 divided by 19, 228 divided by 19 is 12. So A is 12 for 3 marks. Question number 27. The diagram shows a sector, OPQR, of a circle, centre O and radius 8. OPR is a triangle. Work out the area of the shaded segment PQR. Give your answer correct to 3 significant figures. So here we have a quarter of a circle. We can work out the area of the whole circle, and then we can just divide it by 4 to get the area of 1/4. So the area of a circle is pi times the radius squared, and then we're going to divide that by 4 to get the area of just this quarter section. The radius would be 8, okay? So we're going to do pi times 8 squared divided by 4, and that would be the area of the whole thing. To get the area of the triangle, so let's just draw a little quarter circle there. To get the area of the triangle, we're going to do base times height divided by 2. So 8 times 8 divided by 2 is 64 divided by 2, which is 32. Let's now just work out for that quarter circle. So in my calculator, I'm typing pi times 8 squared, and I'm going to divide it by 4, and that is 16 pi. So now all I need to do to get the area of this shaded bit is do 16 pi take away 32. So 16 pi minus 32. You might have done this as a decimal, by the way, in which case it is 50.26548, and then taken away the 32 from that. It really doesn't matter. It's nice to keep it accurate if you can, though, so I would just use 16 pi, and that answer is 18.26548. 3 significant figures, so 1, 2, 3. Check the 6, it rounds up, so 18.3 is your answer there. Question number 9. On Monday, 12 people took 5 hours to clean a number of cars. On Tuesday, 15 people cleaned the same number of cars. Assuming that all the people worked at the same rate, work out how many hours the 15 people took to clean the cars. So the key with this question, this is proportion, is to work out what about if there was one person. So I'm going to start by writing 12 people equals 5 hours. And I'm going to say, well, what if there was one person? Now, the thing with this question is that we need to realise if we've divided the number of people by 12, we're not going to divide the time by 12. Because if there are 12 times less people, it's going to take 5 times longer. It's just common sense to think about if you've got less people doing a task, it's going to take longer. So that is inverse proportion. So if we divide the number of people by 12, we need to times the amount of time by 12. So 5 times 12, it would have taken 60 hours for one person to do the same number of cars. On Tuesday, we've got 15 people. So we've now multiplied the number of people by 15, in which case we would be able to divide the amount of time taken by 15. 60 divided by 15 is 4 hours. So it would take 4 hours if there were 15 people like there were on Tuesday. The assumption is wrong. How might this affect the time taken for the 15 people to clean the cars? So the assumption is that all the people worked at the same rate. So if some workers are slower, it would take more time. And you could say the opposite. You could say if some of the workers were quicker, it would take less time. But they're just looking for you to understand that relationship. Question number 11. Freya writes down the value of x correct to 1 decimal place. She writes x equals 6.4. Complete the error interval. So what they're asking us for here is the biggest and smallest that x could have been before she rounded it. So it's been rounded to the nearest 1 decimal place, which is the same as rounding to the nearest 0.1. Now, whatever you've rounded to the nearest, you're going to divide that by 2. So divide by 2, and that is 0.05, and that tells you how much to put above and below this number. So at the upper limit, we're going to have 6.45, and at the lower limit, we're going to have 6.35. Now, I know what you're going to be thinking. Hang on, 6.45 would round up, and that's why it doesn't have an equal to at this top end. So we can have any value in between 6.35 and 6.45. We can actually equal 6.35, but it can't equal 6.45 because then it would round up. So we just say everything up to that, and 6.45 is the upper bound. Okay, question number 13. A pattern is made from 4 identical rectangles. The sides of the rectangles are parallel to the axes. Point A has coordinates 3, 4, point B has coordinates 11, 20, and point C is marked on the diagram. Work out the coordinates of C. You must show all your working. Okay, so all of these rectangles are identical. I'm going to say that with each of these rectangles, I'm going to call the little length X and the longer length Y. Just because I can. Okay, so we know that to get from here across to here, that's going to be an X. And then from here across to here, that's also going to be X. However, I only want to go across to this point, which is going to be 11 from 3. So I only want to come across to here. So I actually want to take Y back off. Okay, so I'm getting an expression from 3 over to 11. So I know that to get from 3 to 11, I've gone across by 8. So therefore, this x and this x, subtract a y, needs to equal 8. So 2x minus y equals 8, because we've gone across by 2 x's, but we've come back by y to get from 3 to 11. Now let's look going up in the y direction. So I've gone from 4 here up to 20. So it's 16 bigger. How have I got there? Well, let's have a little look. I've got y here, and then I've got x here, and I've got another x here. So there's nothing to subtract. I've just got y, add x, add x. So 2x, add y, and that we know has gone up by 16. There we go. And what we've got now is simultaneous equations. So I've got minus y and add y. So what I'm going to do to cancel those y's out is add these two things together. 4x is equal to 24. I'm adding this because it cancels them out. And then I'm adding 8 and 16 to get 24. If 4x is 24, then x is 6 because we're dividing both sides by 4. And if x is 6, all we need to do is substitute that back in to either of these. 2 times 6 is 12, take away y is 8, therefore we know if 12 take away y is 8, y must be 4. There we go. We've now got to work out the coordinates of C. Well, to get to C, we can start here at A, which is 3, 4, and we need to go x across and y up. So we're going from the coordinate 3, 4, and we need to go x across, so that means we're going to need to add 6 in the x direction, and then we need to go up by 4, so we're going to add 4 in that direction, and that gives us an answer of 9, 8 as our final answer for that coordinate. Hopefully that makes sense. That is quite a tricky question, so well done if you managed to follow along with that. Question number 15. The graph gives the volume of water in litres in a container at time t seconds after the water started to flow out of the container. Using the graph, work out an estimate for the rate at which the water is flowing out of the container when t is 12. Okay, so let's go, t is 12 here. And we'll go up to the graph here. Now, I want to know the rate of flow at this point here, the rate of flow. That is not found by reading across. If I read across, I'll be able to find out how much volume is left in the tank. But I don't want to know that. I want to know the rate at which it's flowing out. And we get that by doing the gradient. Now, because this is a curve and I want the gradient, I need to draw a tangent. I'm going to go there and I'm going to move it. So I need to draw a tangent, and that tangent needs to match the steepness at that point you're looking at. There we go. So I've drawn it like that. And I'm going to make a triangle out of this. Now your triangle can be as big or small as you like. I'd like to make it as big as I can because what that then does is makes it more accurate. So I'm making a triangle like that. This value here is 28. So this triangle I've made has a height of 28. And going across, we've got 30. So I'm going to do, to get that gradient, the gradient is found by doing rise over run, or change in y divided by change in x. So that is 28 divided by 30, and this gradient is negative, it's coming down. So, but equally, it doesn't matter for this case because it's saying estimate the rate at which the water is flowing out. So that's fine if it's a positive value here. So we've got 28 over 30. Oh, use my calculator. 28 over 30 is 0.93 recurring. So I'm going to pop 0.93 recurring there. The mark scheme allowed anything from 0.7 to 1.1. It obviously did need to be correct to your graph, but that was what the allowed range was. So to your tangent that you drew, it had to be correct, but that was the range that you were allowed. So people might have drawn their tangents slightly differently. I got 0.93. So there we go. Number 17, x is directly proportional to the square of y, and y is directly proportional to the cube of z. Z is 2 when x is 32. Find a formula for x in terms of z. Okay, so we've got two different formula here and we're going to try and combine them. So x is directly proportional to the square of y. If you watch my videos, you know I often say you can't solve equations with fish in them, so we need to change it for an equals and a k. So x equals k y squared, and we also have y is directly proportional to the cube of z. Now normally we would always use a k, but because we've already used a k, I want to use a different letter. I'm going to use j. Why not? So y equals j z cubed. Now we want to try and combine these because I've got a value for z and a value for x, but they're in different formulas at the minute. But I do know that y is j z cubed. So if I want y squared, I can square this, so y squared is j z cubed squared, and I can substitute it into the other formula. So y squared is j squared z to the power of 6, and I'm going to substitute that in for here. So x equals k j squared z to the power of 6. Now let's use the values that they've given us. So when x is 32, k j squared, and then I've got 2 to the power of 6, and 2 to the power of 6 is 64. So 32 equals kj squared times 64, and if I divide by 64 I get a half. So half is kj squared. Okay, now going back to what I've got here, I want a formula for x in terms of z. Well, now I know I can just change the kj squared part to be a half. So therefore my formula that they're looking for, x equals a half z to the power of 6. We now have a formula for x in terms of z, which is what they wanted. Let's pop that on the answer line. X equals a half z to the power of 6. There you go. Question number 19. At the start of year n, the number of animals in a population is Pn. At the start of the following year, the number of animals in the population is Pn plus 1. So this notation looks really scary, but all it means is next year is k times the population in this year now. So to get next year, you're just going to times by k, and then to get the next year, you'll times by k, and to get the next year, you times by k. So at the start of 2017, so the population in 2017 equals 4,000. At the start of 2019, the number of animals in the population was 3,610. Now, we don't know what P 2018 is, but we know that it would be 4,000 times by k. And then to get P 2019, which is another year on, it is 4,000 times k times another k, and we know that the answer there is 3,610. So each year we know we need to times by k, which is how we've got that. Okay, so I now know that 4,000 times k squared is 3,610. So to solve this, I'm going to divide both sides by 4,000. 3,610 divided by 4,000 is 0. So k squared is 0.9025, and then we just want to square root that answer, and that is 0.95. There we go. So the constant k is 0.95 for that question. Okay, question number 21. Here is a speed time graph showing the speed in meters per second of an object t seconds after it started to move from rest. Using 3 trapeziums of equal width, work out an estimate for the area underneath the graph between 1 and 4. So I'm going to use my ruler here. I want to work out the area between 1 and 4. And they've asked me to use 3 strips of equal width. So we're going to therefore go like this and make 3 trapeziums. Now, you might prefer to split these into triangles and rectangles, and that's absolutely fine if you do want to do that. I'm personally just going to treat them as 3 trapeziums. So for that, we need to do the area of a trapezium is a plus b divided by 2 times by the height. A plus b divided by 2 times by the height. So these are on their side. This is going to be a, this is going to be b. Divide it by 2, and then I'm going to times it by the height, but the height is just 1 because it's one tall if you were to look at it sideways. Between 1 to 2, between 2 to 3, and between 3 to 4. So the area of this one here is going to be a plus b divided by 2 times by 1. So a is 4, b is 6, so 4 add 6 is 10, divided by 2 is 5, times by 1 is just 5. So the area of that bit is 5. Again, for the next one, this is going to be my a, this is going to be my b, so 6 add 7.2 is going to be that value there. So 6 add 7.2 divided by 2, and again we times that by the height, which is 1, but that is 6.6 as the area. And then for the third bar, again we're going to do a plus b, so that is 7.2 add 7.8 divided by 2, and then times by 1, which gives me 7.5. So the area of those 3 bars, I'm now going to add those values together, and that is going to be 5 add 6.6 add 7.5, which gives me 19.1 as my area there. 19.1. What does this area represent? So the area underneath the graph of a speed time graph represents the distance. So the distance travelled between 1 and 4 seconds. That's how far it travelled from 1 second up to 4 seconds. Okay, question number 23. And this question is particularly difficult, okay? So what I'm going to do is I'm going to start by going round this triangle in red, just to show you my working here. And I'm going to go around the other triangle in purple, why not? Just to show you that triangle there. So when I'm just talking about the different triangles, I can just talk about those colours. Great, okay, so firstly, we've got D is the point on BC, such that angle BAD and DAC is x. So both of those angles are exactly the same, they're both x. Prove that AB over BD equals AC over DC. Okay, so all I can do as well is draw in this angle here. I'm going to call this Y, and if that one's Y, then this one is 180, take away Y. And I've got angles, I'm going to use the sine rule here, okay? So looking at these angles and these sides, I'm going to say that BD over sine x equals AB over sine y. So that is just the sine rule using the information that we've been given, and that's looking at the red triangle. Okay, if I rearrange that, I can multiply sine y up and I can divide BD down, and so I get sine y over sine x equals AB over BD. So that's looking at the red triangle. Now let's look at the purple triangle and try and do a similar thing. So I've got, again, using the sine rule, DC over sine x equals, and then I've got this side over here, AC over sine 180 minus y. And again, if we rearrange that, I can bring this up here, and I can bring this down there. So sine 180 minus y over sine x is AC over DC. There we go. So I now have this triangle here, AB over BD, and I have this, fraction, did I say triangle? This fraction here on the right hand side as well, okay? Now, are these two things the same? Well, yes, they are, because sine y is the same as sine 180 minus y. If you think about a sine graph, sine looks like this. It starts at 0, at 90 it's up at 1 at the top, and at 180 degrees here it's back at 0, and it's symmetrical here. So if you have sine of y and you have sine of 180 minus y, you're always going to get the same value because you're subtracting from 180, so it's going to be symmetrical about that 90 degree point, okay? So this is actually the same. Therefore, sine y over sine x is the same as AB over BD, which is the same as AC over DC. And so we've shown that these are the same things, and that's that done for 4 marks. That is so grade 9, so grade 9, if not an A-level question. I think that's a really tricky one to end on. So if that made any sense and you were able to follow along, really well done. But yeah, that is really tricky and a very difficult question. If you've got any questions on today's paper, hopefully you found it helpful, but do let me know in the comments if there's anything you want me to go over again, and I will see you guys next week for week 24.